Hello and welcome back to the section on process management, and in this video we are going to be looking at more commands relating to process management, like the FG for foreground, BG for background, the no hop command. We'll look at jobs, the different process states. We'll also look at the process signals, nice and re-nice, and the top command. If you haven't subscribed to our channel yet, why don't you go ahead and do that right now and hit the notification bell as well. Without further ado, let's get to it. In the previous videos, we have seen how running a process in the foreground is and sending it to the background as well. But we didn't really dwell on the FG and BG command, and that's what I'd like to do in the next couple of minutes. So let's say I fire up the Firefox process, and that's going to open up Firefox. But what you'd notice is I don't have control of my terminal. So internally, the bash shell has spun up a new process which has taken over my bash shell. And now this new process is running in the foreground, and I can't do any other thing except the Firefox process that's running. I'll have to send a signal to the process telling it to pause, and that can be done with a Control Z. The Firefox process has now paused, even though it's showing stopped here. What's going on is it's in a pause mode with a job number 1, and I can confirm that with the jobs command. So to resume this process back, I'll use the BG% and the job ID number 1, and what you notice is it's appended an ampersand to the end of Firefox. If I run jobs again, you can see this Firefox process is running in the background. Now notice this is not running as a service, so if I logged out of this system or there's a shutdown or restart of the system, the process is not going to come up again. So sometimes there is need to run a process for a very long time. Imagine if I'm trying to take a backup of a database. Backing up a MySQL database of, let's say, 50 terabyte is definitely going to take a very long time. And running the MySQL dump command on the terminal in the foreground is definitely not an option, because what happens if I log off or there's a system reboot or whatever? What's going to happen if, let's say, I started running the backup at about 4 p.m. and it's time to go home at 5 p.m. and I don't want to leave my terminal open? I have to lock my screen. Even though I can leave it running in the background like this, there's no guarantee that it's going to remain running in the background after closing my shell. Now, to help us out of this misery, we have a new command which is called no hop. Before I run the no hop command, let's kill this process. To kill it, I just have to pass the process ID to the kill command. And now to run our Firefox command and set it straight to the background right from the get-go, I can use no hop Firefox with the ampersand. And sure enough, it brings back our Firefox browser, and I can safely type my Control C. If I bring out the PS-F grepping for Firefox again, we can see that Firefox is still running. Now to bring Firefox back to the foreground, we can do it the same way we sent it to the background using the BG, but this time around we use FG. Oops, no such jobs. That's because I'm using job ID number 1. But if I run jobs, I can see that the no hop is running on job ID number 2. So bringing back our command and replace 2 with 1. And now we can see Firefox is back to the foreground. And notice this is the version where we use the no hop. With the no hop, we can safely log out of the system, and by the time we log back in, it's still running in the background. Okay, so I'll cancel this with Control C. And the next thing I want to talk about is the process state. Remember in the previous video we were looking at PS-L, and the state column has different states for every process. And currently we have bash process in the S state, and we have the PS process in the R state. Now there are different states in which a process can be, which are represented with R, S, D, and Z. And the reason we have different states is because only one process can run at a time on a single CPU. For any other process to run on the CPU, it has to wait or be in some other state. Meaning if a process is not running, it's either sleeping or waiting or doing something. So the R represents either runnable or running state. Runnable means that all the resources to run, if a process is in a runnable state, that means that process has every other thing it needs to run except for the CPU. So your program doesn't only rely on the CPU, it also needs memory, it needs I/O, and I/O means input, output, which relates to the traffic that the process goes to fetch data from the disk or from the memory. Therefore, if the disk is available, the memory is available, but the CPU is not available, then it's considered to be in a runnable state. It's able to run but not running just because the CPU is not available. The same R represents running states, in which case all the resources it needs to run, memory, disk, and CPU, are all available, and it is indeed running on the CPU. The other state a process can be is the sleeping state, which could be interruptible sleep or uninterruptible sleep. Whether it's interruptible or uninterruptible, it means that the process is waiting on some resources that is currently not available. And interruptible sleep is represented with a capital S, while the uninterruptible sleep is represented with a capital D. So anytime you find these alphabets under the S column, then you can interpret what's going on with that process. The major difference between interruptible and uninterruptible sleep of a process is how the process can handle a signal that it receives. Every time you press Ctrl Z or Ctrl C, you're essentially sending a signal to that process. So if the process is waiting for a resource to be available to go into the running state, and while it's still sleeping, it's able to respond to a signal, then it's an interruptible sleep. But if it's in an uninterruptible sleep state, the process won't be able to handle any signal right away until that resource or whatever else it's waiting for becomes available. Then it'll be able to handle whatever signal that gets sent to it, or perhaps after a timeout occurs. So if it's sleeping because it's waiting for something, if there was a configured timeout for it to sleep, let's say the program has been configured to wait for 30 seconds. After 30 seconds of waiting, it has to get out of the sleep. Now, if that timeout passes, then that's the only time it'll be able to respond to any signal that comes to it. So that's the major difference between the interruptible and uninterruptible sleep. Now, the final state is when a process becomes a zombie or it's defunct, and that's represented by capital Z. To explain this better, remember the process ID and the parent process ID, which is PID and PPID. Now, when the parent process dies before it releases the child process, then the child process becomes a zombie. And at that stage, you would see PS telling you with a capital Z that, hey, this process has now become a zombie. It is an orphan process. It doesn't have a parent process anymore. So back on our terminal, you can see the capital S, which is the state of each of these processes. Right under that, you would see the states S, R, or Z, or D, depending on what state the process is. And finally, let's talk about signals. Every time we execute Ctrl Z or Ctrl C to either pause or stop a process, what we're doing is sending a signal to that process. And these signals are represented by different code using the kill command. So if I do kill -L, you would see all the different signals that you can send to a process. There are 64, however, there is about 5 of them that is commonly used, and I'll just go through them quickly. And that's the signal 1, 2, 3, 9, and 15. So if you want to stop a process and ensure that it restarts with the same process ID, you would use the kill command to send sighop. And the way to send such signal would be to run kill, then you specify the number with a flag, and then the process ID. So let's say we start up, let's clear the screen. Let's say we start up gedit by sending it to the background with the no hop command, gedit. Okay, and let's do a grep of gedit. From PS. Now we know that gedit is running with a process ID 23630, and that's the process right here. Now to stop this process and start it again with the same process ID, I'll send the signal number 1 to the process ID and as you can see, I've run the kill command, but it's still running with the same process ID. So if there are other signals you want to send to a process, you can just go into kill -L to list all the different signals and pass the number that you intend to send to that process. The number 2 signal, which is sigint, that's the signal that gets sent to a process when you do Ctrl+C. And this is considered as the weakest kill because it interrupts the process. Number 3, which is the sigquit, kills the process and does a call dump memory to a file. Usually that happens when you do a control with a backslash. You can try that out. Number 9, which is the sigkill, is also considered as the absolute kill. And with this signal, that is when you forcefully stop a process and send whatever message to a null device. And the final one I like to talk about is the number 15, which is sigterm. Now that is the default that happens if you don't specify a signal number from the kill -L that prints out all the 64 signals. Sigterm is the default signal that gets sent to a process if you don't specify any number. That's the default. Now if you're interested to know more about all of these 64, you can go through the man page for kill or do a bit more research on Google. In the next video, we are going to be looking at nice and renice and the top command. I hope this video has been very informative for you. If you haven't subscribed to the Diary.io channel, do subscribe and hit the notification bell to get updates. I'll see you in the next video.